A signal is sent today from the edge of the observable universe, a final, desperate message from a galaxy named GNZ11, perched 46.5 billion light-years away in co-moving distance. That signal will never reach you, not in a million years, not in a trillion. It is already lost to the void, an echo swallowed by an impossible silence. This isn't a technological problem we can one day solve. It is a fundamental law of reality, a rule etched into the very code of space-time. For every photon, every graviton, every ripple of information, there is an unbreachable barrier defined by a single, immutable number: 299,792,458 meters per second. The speed of light. We call it c. But it's more than a speed. It is the ultimate cosmic speed limit, a governor on the engine of reality. This isn't just a limit on how fast you can travel. It's a fundamental prison, trapping us within a tiny, fleeting fraction of all that exists. To understand why this barrier is absolute, we have to rewind to 1905, to a patent clerk in Bern named Albert Einstein. In his paper on the electrodynamics of moving bodies, he didn't just propose a theory. He re-architected reality based on two deceptively simple postulates. First, the laws of physics are identical for all observers in uniform motion. Second, the speed of light in a vacuum is the same for all observers, regardless of the motion of the light source or the observer. This second postulate shatters our everyday intuition. If you're on a train moving at 100 kilometers per hour and throw a ball forward at 20 kilometers per hour, someone standing on the platform sees the ball moving at 120. But if you shine a flashlight from that same train, both you and the person on the platform measure the light speed as exactly c. It doesn't add up. It defies common sense. And that's because our common sense is wrong. To make this cosmic law hold true, something else has to give. And that something is space and time itself. The universe bends to preserve the constancy of light. As an object approaches c, its experience of time slows down relative to a stationary observer. This isn't a trick of perception. It's a physical reality known as time dilation. The math derived from the Lorentz transformations is unforgiving. For astronauts on a ship traveling at 99.9% the speed of light, only 1 year might pass, while back on Earth over 22 years would have elapsed. Their clocks literally tick slower. Simultaneously, the universe contracts in the direction of their motion. This is length contraction. The distance to their destination physically shortens from their perspective. Time and space are not rigid absolute backdrops. They are a malleable, intertwined fabric, space-time, that warps and distorts to ensure no one ever breaks the one true law: thou shalt not outrun a photon. But why? What is so special about this speed? The answer lies in the very nature of mass and energy. Einstein's most famous equation, E equals mc squared, is the key. It tells us that mass is a form of concentrated energy. To accelerate an object with mass, you need to pump energy into it. As you approach the speed of light, the energy required to go even a little bit faster skyrockets. The Lorentz factor in the full relativistic equation shows that as your velocity approaches the speed of light, the object's relativistic mass, its inertia, its resistance to further acceleration, approaches infinity. To reach the speed of light would require an infinite amount of energy, more than exists in the entire universe. Only massless particles like photons can travel at this speed, because they don't have to fight against their own inertia. They are born at the speed limit. This speed limit is not just a cosmic traffic law. It is the very architecture of causality. Think of your existence as a light cone. Your present moment is the vertex. Your past is the cone stretching behind you, containing all events that could have possibly affected you, events whose light has had time to reach you. Your future is the cone stretching forward, containing all the events you can possibly influence. Anything outside this cone is in your elsewhere. It is a region of space-time so disconnected from you that you cannot affect it and it cannot affect you. An alien civilization could be having a supernova in the Andromeda galaxy right now, but that event is outside our present light cone. We won't know about it for another 2.5 million years. The speed of light, therefore, is the speed of cause and effect. It is the rate at which information propagates through the universe, the speed at which one event can know about another. To travel faster than light would be to travel backward in time, to arrive before you left, to shatter the logical sequence of cause and effect. It would break the universe. So this isn't a prison built of steel bars, but one woven from the very logic of existence. But how can something so essential to our understanding of reality, so fundamental to the flow of time and causality, also be the ultimate cosmic handcuff?
That cosmic handcuff isn't static, it's tightening. The absolute barrier of light speed, established by Einstein's special relativity, was just the first layer of our confinement. A decade later, his general theory of relativity revealed a universe far stranger and more dynamic than he had ever imagined. A universe where the prison walls themselves are actively moving away from us. Building on his revelations, we now know the universe isn't just a vast static stage, it's an expanding, accelerating entity. The very fabric of space-time itself is stretching, carrying distant galaxies along for the ride. And here is the paradox that redefines our prison. Beyond a certain point, those galaxies are carried away from us faster than light can ever hope to cross the ever-increasing gulf of space between us. This sounds like it violates the ultimate speed limit. It doesn't. The rule that nothing can travel space faster than light remains unbroken. The galaxies are not firing up hyperdrives. Instead, the space us and them is being created, expanding like the surface of a balloon being inflated. An ant on that balloon surface has a top speed, but if the balloon inflates quickly enough, two ants can find themselves moving away from each other faster than either could ever crawl. This is our reality on a cosmic scale. The evidence for this staggering concept began accumulating in the 1920s. Astronomers like Vesto Slipher observed that the light from distant nebula was almost universally shifted towards the red end of the spectrum. This is cosmic redshift, a Doppler effect for light, indicating that these objects were moving away from us. In 1929, Edwin Hubble synthesized these observations, proving a direct relationship. The farther away a galaxy is, the faster it recedes. This is Hubble's law. It was the first concrete evidence that our universe was not eternal and static, but had a dynamic history, a beginning. For decades, the great cosmic question was whether this expansion would continue forever or eventually slow down in reverse, leading to a big crunch. The answer, discovered in 1998, was more shocking than anyone anticipated. Two independent teams of astronomers, the Supernova Cosmology Project and the High Z Supernova Search Team, were using Type 1a supernova, incredibly bright, standardized stellar explosions, as cosmic distance markers. They expected to see the expansion slowing down due to gravity's pull. Instead, as reported in landmark papers in 1998 and 1999, they found the opposite. The most distant supernovae were dimmer than they should have been, meaning they were farther away than predicted. The expansion of the universe is not slowing down, it's accelerating. This Nobel Prize-winning discovery implies the existence of a mysterious, repulsive force permeating all of space, a substance or property we now call dark energy. According to data from NASA's WAPMAP and the ESA's Planck satellite, this unknown entity constitutes a staggering 68% of the universe's energy density, and it is actively pushing our cosmos apart at an ever-increasing rate. This is where our cosmic prison becomes truly inescapable. The accelerating expansion creates a boundary known as the cosmic event horizon. This isn't a physical wall, but a point of no return. Right now, that horizon is about 16 billion light-years away. Any galaxy beyond that line is receding from us so fast due to the expansion of space that light it emits will never, ever reach Earth. It is caught in a current of space-time that is flowing away from us faster than light speed. We can still see the ancient light from when those galaxies were closer, but the objects themselves, as they are right now, are lost to us. They have crossed a causal boundary and have been effectively erased from our future. The cosmic horizon is constantly receding, and with every second that passes, more galaxies cross this threshold, vanishing from our potential future. We are living in a universe where the ultimate truth is perpetually slipping away. The grand cosmic narrative is being edited, with entire chapters being redacted before we have a chance to read them. In the far, distant future, trillions of years from now, our galactic descendants will look out into a sky devoid of other galaxies. The evidence of the Big Bang, of cosmic expansion, will have been stretched beyond detection. They will live in an island universe, trapped in a void, perhaps believing their galaxy is all that has ever been or ever will be. We live in a grief-privileged epoch, a fleeting moment where we can still see the echoes of our cosmic origins before the eternal darkness closes in. We are not just prisoners of the speed of light. We are prisoners on a shrinking island of knowledge, watching as the rest of reality is carried away on an accelerating tide of space-time.